Welcome to the course AI for System Design. Today we are going to launch a new course, basically System Design for AI Systems. AI is everywhere today. Doctors, engineers, businessmen, athletes, everyone use AI. It has grown beyond engineers, research labs, developers to a scale that almost everyone in the world might have used AI by now. So here is actually the interesting part, like how well the piece of software sit as a solution for all the wild problem or use cases we have today in our day-to-day daily life. Obviously, big three names comes in like GPT on how well it interprets the human emotions, or Cloud how excellently it achieves all kind of intellectual tasks like code generation or research, or maybe even Gemini for that reason on how well it interprets human language. But very few people actually talk about what it actually takes to build product around them, and very few people actually succeed in building the product around them. Think about this, like how ChatGPT remembers the context. How does it know something you have told it like 2 to 3 weeks ago? Or maybe how does it retrieve the information? How does it understands, let's say you uploaded 200 to 300 page PDF. How well does it extract the information and answers queries so fast? Consider how difficult it is for a normal average human to do it so quickly in so limited amount of time. Fascinating, right? This software is so powerful. AI is incredibly powerful and incredibly robust to almost fit in all the solution we have. But how do we do that? How do we fit in our solution? So these are not actually machine learning questions anymore. These are system design questions. Systems, yeah, all the existing systems on almost all the upcoming systems are leaning very fastly towards AI. Everyone wants to automate tasks, everyone wants to eliminate boilerplate tasks, and all these are achievable easily through AI. But how do we do that? How exactly are we going to get this work done? So that's what we are going to go through in this course. Myself, Frank, I have been working around in this AI ecosystem for like last 2 to 3 years, trying to keep up with all the rapid advancements we are going through, experimenting, researching so many of them to arrive at a better conclusion and build a better systems. So and also to keep up with the pace of innovation on how fastly we are going through in this AI dominated era. So I present you this AI system design course, a course where we'll explore the principles, architectures, and engineering decisions behind real world AI applications. So we'll go beyond models and learn how complete AI products are designed from end to end, and we'll break down the systems powering modern AI applications and understand the trade-offs within it. Without wasting much of our time, let's dive into the course. So basically this is chapter 0, so introduction and foundation, where I'm not going to actually teach or discuss any techniques or technologies, so you're free to skip this part if you're not interested. We'll basically just go through the whole course, like what is this whole course about. We'll just go through what are we going to learn in this course, who this course is designed for, and probably what I want you guys to do to get maximum out of this course. So this course is all about basic to advanced, as I told. So we'll first discuss on the fundamentals and basic terminologies, where we are going to just see on basic things, which will help us in understanding complex architectures later. Then we'll go through LLM application architectures, where we'll take down some small scale applications involving LLMs, and how do we understand the whole data flow from beginning to end. Then we'll pick up AI infrastructures, where we take down a bit of complex architectures and just analyze them end-to-end pipelines, so that we can have a proper understanding of how the modern day production level infrastructures are designed. Then we'll go to production engineering, actually, where we basically focus on optimization tasks, for example cost cutting down, or maybe limiting the LLM calls and so on. So this will be focusing more on optimization part. Then we'll go to advanced AI techniques and systems, so upcoming innovations and upcoming complex data structures, on how well we are going to include them in our solution, where do they fit well in our solution, and what are the cases where we can implement them in to solve our problems. So we'll be focusing that in the later part. and at last we'll be focusing on one big whole complex system. We are going to get a whole big complex system, maybe like GitHub Copilot or Cursor or something, and we'll break down the whole thing into some smaller modules so we can understand how they perform and how well they are designed. Well, who is this course for? So I have tried my best to structure this in such a way that maybe any non-tech person can be able to make much sense out of it. It's not basically more of a hands into coding kind of course, but it's more of like and improving your decision making in terms of AI systems, and to be aware of so many different technologies and techniques. So at the end of the day, you'll be able to build a better system out of it. So anyone interested can be part of it, but yeah. Prerequisites, basic programming, backend and database fundamentals. It's always good to have these things in your armory, but yeah, it's not actually necessary. As I told, it's not a programming course where we'll be teaching how to construct APIs or how to build CRUD functions. We'll be basically focusing on the design skills for building a system. So yeah, it's good to have, but it's not mandatory. As well, familiarity with APIs and traditional design concepts. Familiarities with APIs is also good to have, but not mandatory. Traditional design concepts, this is basically referring to the actual system design concepts like load balancer, circuit breakers, and so many things, which are not necessary at all, but it's good to have if you are more on interview oriented part. If you are focusing more on interviews, then it's good to know these things as well, but yeah, it's not necessary at all, the both the things. Basic understanding of AI, ML and LLMs, although I'll try to give you a complete overview in the fundamentals part. Basic understanding of AI, ML things is also good to have. And willingness to build, experiment and debug real world systems. This is what we'll be trying to achieve more, and I also want you guys to be enough curious and be enough committed to this course to get these things done. Course structure. Well, the whole course is designed and broken into 16 parts, where basically with the first part we are going to focus on the foundation part, where we are going to have a brief introduction on AI system and anatomy of an AI system. Basically we'll break down a whole design layer on how this whole AI systems are basically designed in productions. Then we'll go to AI infrastructure part, where we'll be focusing more on how inference in model LLMs occur. So basically this is also part of fundamentals, where we actually be aware of some of the techniques used in basic traditional system design modules, and also some multimodal architecture, like multimodal architecture in the sense, I just don't want you guys to be confused with handling multiple data types or handling different kind of data inputs. We are going to be focusing on having multiple LLM models being used in the same architecture. So we are going to see that in this particular chapter, on how we can have multiple LLMs and route them according to their capability of the tasks. So then we'll be focusing on context engineering. This part will be helpful in the interview interview kind of point of view, basically on how these LLMs will be able to capture the context, and how we are going to basically handle the context with very less amount of token consumption. So we'll be focusing on all these things in the upcoming lectures. Then the memory systems. This is basically kind of backbone of the whole agent system, whatever you build. So there are different kinds of memory we can able to you make use of. So we'll be discussing all of them in this particular chapter. Then comes retrieval systems. This is probably the most hot topic in AI domain now. So retrieval, in this particular part we are going to discuss solely about how do we retrieve information from any source, be it database or be it any file or anything. So we are going to discuss about some of the main important techniques and strategies. So we are going to go through them in this particular chapter. Then we'll also go through some advanced structure. So this is basically knowledge graph. So we are going to go through how this advanced structure is also being utilized and how we can make much use of it. Then advanced retrieval architecture. So basically whatever the information we retrieve in the chapter 8, we are going to bring them into production. We are going to use them in our production. How are we going to use the documents, whatever information whatever we have retrieved, will bring the whole end-to-end pipeline for this whole retrieval architecture. So then we are going to also see retrieval augmented systems, where we are going to see the RAG. So whatever retrieved here will be basically utilized here. So we are going to see so many chunking strategies and how well you can actually get the LLMs to know the context of what you are going to search, what you're searching in the whole document. So we'll actually break down the how well ChatGPT does this and how well some important and famous systems do this. We'll break down all the strategies in this particular chapter. Then we are going to see some advanced RAG architectures. So there are so many different techniques, so many different variety of experiments being done in this RAG particular field. This is a whole different field. So there is so many things being done almost every day. So we are going to see some of the advanced architectures that are going to be helpful and be handy in future. So we are going to just have a brief about these advanced architectures as well. Then comes important part, the buzz of the whole AI, the agents. So we are going to see the first we'll start with the foundations, as this is some important topic. So we'll start with the foundation part and the design patterns for any AI agent. Then we are going to see a tool ecosystem. So basically how do AI get to use tools. So how does agent differ from LLMs, normal LLM chatbot. So we are going to just get a overview about that as well in this particular chapter. And then we are going to also see model context protocol. So basically MCP servers and clients, how they are used, what are they. So we'll basically start from fundamentals and reach to a level that we can use them in our day-to-day daily use cases. Then we'll also see some agent runtime systems, like how do we deploy, once deployed, how do you handle them. These strategies are not so much important in terms of interview part, but yeah, it's also good to have kind of knowledge. So we are going to go through this as well, the whole workflow of the AI oriented systems. There are so many different workflows other than the RAG and agentic ones, so we are going to have a look around them as well. Then comes human AI collaboration. So basically this is quite important in terms of interview perspective, where you get to know where does actually human intervention required, where is the limitation for AI to stop, where do you know that AI has to stop and human had to intervene. So we'll basically see the human in the loop systems in this particular chapter, and how well you can design according to the particular requirements. Then we'll see structured AI systems. Basically this comes so handy in production or development phases. So how well you can get the AI to give response as per whatever the structure I want. So we'll just go through this. Then we'll see multimodal systems. So basically we'll build some system pipelines which will handle all kind of documents, basically OCR for image and document understanding and vision language models for images and or even videos for that reason. So we'll see all of those audio systems and video system in this particular part. Then we'll see the reliability engineering, the production engineering which we talked about. So we'll see what should we do if we encounter some particular failure, and we'll discuss on different kind of failures that can be possible in the production, especially hallucination, where we'll dedicate some amount of time for this, which is so hot topic in terms of AI interviews. So we'll see that as well. Then we'll see verification architectures, where we'll see the response given by AI, how do we verify those responses are right for our problem statement. Then we'll also see evaluation engineering, so we'll basically also go through evaluating the AI responses. We'll test how accurate our prompts are, how well our responses are basically in this particular part. And then security engineering, so how secure are our platforms going to be. So we'll basically focus on that part here, the agent security as well as the LLM security. And also we'll discuss on some techniques on which we should be taking care of while designing any agentic systems. So and at last we'll see on the operation engineering, where we try to firstly we'll try to take care of this monitoring and observation and logging kind of things, where we basically understand all the operations which has to be done after the deployment and after the design, what else has to be taken care of. And then obviously cost engineering, where you try to, once the system is built, you start optimizing it to a level that it reduces your cost as much as possible and gives you a better performances all over. And last we'll be concluding with the data engineering for AI. So basically in this particular chapters we'll be going through the whole data flow. We'll analyze whatever we have learned so far. We'll go through the whole data pipelines and how well AI systems can fit in the completely data oriented projects. And at last we'll start with the final research systems, like we build some frontier AI architectures, like building multiple research agents, search planning agents, and so on. So we'll start with one particular designing system. We'll design a complex architecture and break down the whole complex architecture into some smaller modules, and basically know how well they work. And as a part of advanced architecture, this will also go through a reasoning system, where we design an advanced research agent as well, alongside designing some deep research systems. So we'll basically design multiple kind of agents in this module basically. So we'll first design a research system and then reasoning system. We'll also design a multi-agent architecture, so basically orchestrating multiple agents in itself. So we'll be focusing on this part as well. So basically this is the whole overview of course, like what we are going to study. So this is the whole course structure which we are going to go through in the whole meantime. So this also brings us to the question, like, why do we need AI system? What is the requirement for it? So basically this is a whole rapidly evolving field. Like the whole AI system, what we see is being rapidly encouraging exponentially, especially in last 1 or 2 years. What we have seen, it has been rising so much. And also the outputs generated by these AI systems are not actually deterministic. They're more of like probabilistic and heuristic terminologies I'll be explaining in the next one. But so let's say like 2 + 3 = 5. So this is actually deterministic, but what AI response it gives, it's actually quite heuristic and probabilistic. Like you can't, it's not always a definite output what AI gives. So it becomes so important that you design your system in such a way that the probabilistic output whatever AI gives aligns so much with the solution you are expecting for. So this outcome driven engineering is the focus of this AI service layers what we are going to design so far. So so this is why that it differs from the traditional system design, where we focus mainly on the scaling part or fault tolerance, or how does the system respond if there is some of the internal system breaks down or something. So that is the traditional system design, where you focus mainly on these things. But here we are more on outcome driven engineering, where we mainly focus on how to get maximum of the outcome with a limited resource as much as possible. So that is why that's what we are going to discuss, and that's what we are going to design. And we are also going to discuss a bit on the trade-offs which extend beyond performance. So in basic system design, what happens is that the whole deciding factor is basically the performance, how well the system performs in so and so difficult conditions, how well your system perform for 1 million user, how well your system perform for 100k users or something like that. but here we are going not focusing more on the scaling part, but we are going to focus on the trade-offs, like how much of API calls do you need to make to get the response, how much of cost it takes, how much of tokens you are consuming, how much of context you are giving, how well the memory is being used. So we're going to focus mainly on those parts. Then how to get maximum out of this course. So basically it's quite important that you focus more on the techniques and the design principles we are going to incorporate when arriving a solution, rather than the whole solution itself. So I want most of you guys to focus more on how we are going to arrive at the solution, what are the decisions we are going to make, what are the factors we are going to consider in making the whole solution. So the pipeline designed, it's temporary, but the decisions we take, the decisions we make, and the factors we consider in designing the whole pipeline is decisive. So I want most of you to focus on more on those things. And we have to basically design so many kind of systems. So we'll at the end of the course we'll be having 20 to 30 kind of different designs of various systems. So I want you guys to assess all the systems whatever we have, and see how we are going to choose among the different trade-offs we have. Some places we might have to give focus we have to more focus on the context part, where you be okay with the token usage, and some parts you might not actually be happy with the token usage, and focus less on the context part. So there are so many different trade-offs which we can see in the upcoming course. So I want you guys to focus more on those trade-offs as well. And last one is common in almost everything: practice, practice, practice. So I want you guys, there might be some of the works which we can leave over. So I'm not going to design whole engine or whole product by myself. So I'm just going to give you an overview and direction on how to achieve it. But I want some of you guys to at least try out the exercises if possible, like the basic blueprint or the layout which I give you. I would just want you guys to follow it on and practice the whole techniques which we discuss in this particular part. And lastly, an interview framework. So basically so this is basically for interview perspectives only. I just wanted to share this with the end of the chapter, so this is basically what I read from a proper famous system design book. Actually, if it's called as System Design Interview Preparation Book, written by Alex Shu. So how do you answer in an interview? So basically it focuses on that particular framework. So an interview framework is basically like how are you going to answer any questions in an interview, especially system design interview. So I just thought we'll throw some light on this one as well. So firstly, you understand the problem, you understand and establish the design scope. So let's say if someone say I want a normal chatbot, so you understand the whole problem, like what exactly is the requirement of the user, and then you establish a design scope. Like you just don't directly come into the conclusion, you just get to know the whole ecosystem in what you're designing, and what are the requirements, and what are the things you have in your hand, what are the things that needs to be extracted, everything. You just start to more of establish yourself in the whole design scope. Then you propose a high level design and get the buy-in. So you directly don't dive into design yet. Once you have all the abstract decisions made, you just pitch into the interviewer that these are the kind of designs I have done, how do I approach further, and get the confirmation of all the assumptions you make that they are valid enough, and and also considerations you are going to make, just be sure that they are allowed. Then you start to design in deep dive. So basically you get into designing things. You don't have to write any boxes for the sake of it. You just have to know what you're going to do, the layers you are going to build. It better be required, and you just don't draw any unnecessary things, or just don't build or include any things that are not necessary for the problem statements. So this part, basically you start to design the whole things, and then a wrap up. So basically you start to get into feedback. So you keep on interactively talk with the interviewer on how the system what you have done is aligning with the actual solution what needed. And also I want to say that there is actually no perfect solution in this whole system design. So there is no perfect solution for any particular problem. Whatever the solution we have, it's probably a better solution, or the solution which the user requirements are mostly covered up with. So basically you're not expected to design a perfect architecture for any of the systems you're going to design. They basically expect you to design an architecture in such a way that it has most of the things covered. So basically you ensure that throughout the whole thinking process as well as the designing process, and just make sure that you have covered and tick all the boxes. So then you wrap up the things. So basically this is the interview framework discussed in that particular book. I'll add the book link in the description as well. So yeah, this is our course. This is what we are going to do in upcoming days. So yeah, that's it for the first chapter status. We'll come up with a new lecture, Foundation for AI Systems. Thank you for watching.